So in this video, we will be discussing about maps. Okay, what are the important characteristics of maps and how we can use them? That is very much important to understand for interview perspective as well as for project perspective. Okay, so let's understand that and let's dive deep into it. So first, we'll start with hash map. What is a hash map? A hash map is something which takes data in key value pair format. Okay, so it is not being kept as a part of collection interface, but it is a part of collection framework. So why it is not kept as a part of collection interface? Because it accepts data in key value pair format, which is entirely different than if you compare with other data types like list, queue, set, linked list, array list. If you just compare with these type of operations, they are having certain different type of operation. For add operation, for delete operation, it's like entirely different. They don't uh, accept data in key value pair format. Okay, so that's why it has been kept separately. Okay, and in this, key should be unique and immutable. And immutability, you know, right? A string is immutable class. What does that mean? Okay, so it means that if you are assigning a particular reference variable or an object, if you are creating, then you are assigning a certain value to that variable. Okay, and then if you are trying to modify that existing variable with a new value, then what it will happen, it will not change the existing variable value, rather it will create a new instance in the heap memory. Every time you try to append or try to modify the existing variable, it will try to create a new variable for that. Okay, new object it will try to create. So this is, means immutability. So string is key part is made as immutable. Okay, in hash map, and it is unique. It can't be duplicated. Key can't be duplicated. Okay, and value can be duplicated. Okay, so this is very important. If you can see this screen, okay, I hope you can see the screen. So in this, you can see this is a whole full structure of a map. Okay, so from here you can observe like there is certain thing called as dictionary. Okay, then within the dictionary there is something called as hash table, which implements this dictionary class. Then comes abstract map. Okay, abstract map is one of the class which implements map interface. Okay, so whatever you can see in yellow color, those are interfaces. Okay, and whatever you are seeing in blue color, those are abstract class. Green colors are main class. Okay, normal class. Then with red color, if you can see, those are implements sign. So class is implementing an interface, that is, it's trying to show that. Then normal black colored line, if you see, that is extends, like one class extends another class. So these are the ways of showing the inheritance properties between various categories of map. Okay, so if you can observe over here, there's certain thing called as hash table. Okay, so hash table is a class which extends dictionary class. The purpose of the dictionary classes in Java is to provide a basic framework for creating associative data structure, allowing developers to map key with the values. Okay, so however, the dictionary class is considered legacy and is not commonly used in modern Java language. The primary purpose of dictionary class is to serve as a base class for concrete subclasses such as hash table and property, which provides specific implementation of key value mappings. And you can go with hash table, okay, because it's synchronized, it is thread safe. Okay, then comes hash map. Okay, so if you can see here, it's a hash map. So hash map is a class which implements map interface. Okay, so map is top of all this. Map is a supermost interface for all these classes, abstract classes and interfaces. Okay, so it's kept as a different collection interface. Okay, then there is certain thing called as linked hash map. Okay, linked hash map is a class which extends hash map. Okay, and in turn it extends interface as well, which implements map interface as well. Okay, then there is certain thing called as identity hash map. Okay, it implements map interface. Then there is weak hash map, which implements map interface. So weak hash map is nothing. The word weak here means it corresponds to the reference variable. So as soon as the reference variable is being used up as a key, then there is a garbage collector which keeps on monitoring the keys of that weak hash map. And then after a certain time interval, if it finds that the key part is being already used up and there is no one who is pointing to the key of weak hash map, then garbage collection, what they will do, it will remove the key from the heap memory. Okay, so that is the advantage of weak hash map. Then it's enum map. Okay, enum map is faster than hash map and stores the data if we are making use of enum format. Okay, so it is much faster as compared to hash map. it extends abstract map. Okay, so abstract map is a abstract class. Okay, so these are the classes which extends Hashmap. 1, 2, 3, 4, 5, 6, 8 implementations are there for abstract map, abstract class. So this is important. So this concurrent skip list map, we don't need much. Okay, so apart from this, all this can be asked in the interview. Okay, so what is a hash table? What's the internal implementation of hash table? Okay, internal data structure of hash table. So internal data structure is hash table only. Okay, so basically internally it is making use of hash code mechanism to do the search operation. Okay, so mainly for search operation, hash table is preferred. Then comes weak hash map, you have learned, then enum map, then tree map. Okay, so tree map is a class which extends this abstract map class, and in turn which implements navigable map interface. Okay, so here comes a sorted map. Okay, sorted map is basically for sorting purpose. So internally it is making use of comparator. Okay, so it compares the existing data with whatever new data is coming. Okay, and if it is greater or smaller, it will modify it accordingly. Then comes concurrent map. Okay, so concurrent and synchronized map. So one more map is there called synchronized hash map. So what's the difference between synchronized hash map and concurrent hash map? That is also a good interview question. Okay, so that will be learning. Then navigable map is there. Then concurrent navigable map. This is not much asked. Navigable map and concurrent navigable map. This is not much asked. So the most important things which are asked in the interview is concurrent hash map, synchronized hash map, which is, I think it's not there here, but synchronized hash map is also there, which implements this concurrent map interface. Synchronized hash map, concurrent map, then tree map, enum map. In this part, if you can see, this part can be asked in the interview. Okay, concurrent skip list map will not ask. Navigable map, concurrent navigable map will also be not asked. So apart from this, rest all part, if you can see, interviewer can ask you. And apart from that, synchronized hash map is missing over here, that also interviewer can ask. So let's go step by step. Which is important, that only we will be explaining you, not more. Okay, so here you can see there is a separate categorization between hash map, linked hash map, and tree map. So with respect to time complexity, if you can observe, hash map is having O of 1 time complexity. Okay, so because the data is stored in the form of buckets. Okay, so if data is stored in the form of buckets, and then we are finding out the index, so index will from index you will get to know like which bucket it will point to. And then as soon as the bucket is being found, there we will store that key value pair. Okay, so that's why its time complexity is O of 1. It's constant time complexity because we are not iterating through the entire hash map. Okay, but in case of worst case scenario, let's suppose in a particular index, okay, in a particular bucket it is going, and then there is a means all the elements in a hash map is lying onto the same bucket. So there may be a worst case scenario in that case I am telling you. So what it will happen, it will create a linked list kind of thing. Okay, so all the data will be stored in the form of linked list, and it will be stored there. Okay, so in that case what will happen, so there will be a threshold period. Okay, so threshold size of 8 is there for a particular bucket. So if it crosses that threshold size, then it will get converted into a red black tree. Okay, so in tree again rehashing will happen after that. Okay, so after that it will again check whether it is crossing the threshold or not. If it is not crossing, then it will be getting converted back to linked list. Okay, so initially it will be a linked list kind of thing. So if multiple nodes, if multiple elements are pointing to the same bucket of the hash map, then what will happen, then there will be multiple nodes which will get connected in a form of linked list. Okay, but if it crosses a certain threshold of 8, okay, then after that it will get converted to a red black tree, so that performance get improved. So initially what was there before Java 8, the time complexity of worst case time complexity was O of n, but after Java 8 what happened, it got converted to red black tree. Okay, after threshold, so the time complexity has been improved to O of n log n. Okay, so that is the big advantage we must say after Java 8. Then there is certain thing called as linked hash map. Linked hash map is again the same story with respect to time complexity. So the difference is only that a linked hash map is internally implementing linked list hash table. Okay, so basically if we want to maintain the insertion order, then we are going for linked hash map. Okay, so in linked hash map, insertion order is maintained. In hash map, insertion order is not maintained. So let's suppose your order is important. Okay, so you want to capitalize each and every word's first character. So you want the data in order of a particular person. So let's suppose there are 20 person in a list. Okay, and you want to put it in a map and you want to fetch the data after each and every individual person's first name capitalized. Then here the order is important. Then linked hash map is preferred. Then there is certain thing called as tree map. Tree map is used when we have to do the comparison part. Okay, so it internally makes use of compare to interface, compare to method. Sorry, so it compares the existing data with past data, and then it will return by sorting the element. So its default natural sorting order is maintained over here. Okay, so tree map is used in that scenario where sorting is important. Then iteration, it's random. Okay, for hash map it's random. For linked hash map it is sorted according to insertion order. Then tree map, it is sorted according to natural sorting order. Null keys are allowed for hash map and linked hash map, but for tree map it's not allowed. Okay, if key uses natural ordering or comparator does not support comparison on null keys. Then hash map is implementing map interface. Linked hash map implement map interface. Tree map implements map, sorted map, navigable map. Okay. For synchronization, how can you right, hash map, linked hash map, these are not synchronized. Okay, these are not thread safe. So we can make it a thread safe map class using synchronized map method. Okay, so these are the things, it's common for all. Then data structure, it is storing data in list of buckets. If more than 8 entry, it will get converted to balanced tree from linked list. So this part I already told you. And then linked hash map is making use of doubly linked list of buckets. Doubly linked list means both side it will go, right? From end it will again point to start. Okay, so it and the pointer will go from both the side. Okay, in the normal linked list, what will happen? One pointer is pointing from one node to another node, but the second node was not pointing to the previous node. But in doubly linked list, both side pointer will move, like from first to second, second to first. Okay, it's doubly linked list. Then tree map is a red black kind of tree. Okay, self-balancing binary tree. Then application is a hash map is used where there is a general purpose fast retrieval. Okay, for fast retrieval of data, hash map is preferred. Okay, because it's having O of 1 time complexity. So retrieval and putting data into the bucket is much faster. Okay. And linked hash map is used for LRU cache, okay, where insertion and order access element is mattering. Okay, so there linked hash map is important, where order is important. Okay, tree map is used when sorted or navigable features are required. Okay, where sorting is important. Okay, default natural sorting order if you want to use to sort the elements of the map, then you go for tree map. Then requirement for keys, equals and hash code needs to be overridden, not written. It's overridden. Okay, we have to override hash code and equals method. Why? Because if you see that if hash map key is string type, then we don't have to override hash code equals, because it's by default overridden method is being provided with string. But in case of hash map, if you are using employee or if you are using student as a key, then in that scenario we have to override that hash code and equals for that particular object class. Okay, because employee class by default it doesn't have hash code and equals method. So we have to give the implementation like how you want to implement the operations of the hash map. Okay, like on which parameters you want to implement hash map operations. To give that information to hash map, we have to override equals and hash code. Then linked hash map also we need to override. And for tree map, comparator we have to pass, like name comparator or age comparator. Okay, so if you don't pass what type of comparison you want, then it will do default natural sorting order. Okay, I hope you got the clarity. If you have any doubt, you can ask me out in the comment section below. I will be happy to help you. Then there are abstract map implemented classes, which is, if you can see over here, there's identity map. Okay, it is for strong key reference. And weak hash map is the reverse of identity hash map. Identity hash map stores the strong key reference. That means garbage collector will not remove that element from the heap. Okay, so there will be like a strong reference to that in the heap memory. Okay, so there will be one or other element that will keep on pointing to the identity hash map object. Okay, so it is not easily removable from the heap memory. Okay, so if you want to have a data, okay, or an object of a certain map which you don't want to get removed from the heap memory, then you can go for identity hash map. Weak hash map is used where there is a weak key reference. And if you want that after a particular threshold of time, you want that key should be garbage collected. In that scenario, weak hash map is used. Okay. And enum map is also for strong key reference. Okay. Identity hash map and weak hash map both, sorry, identity hash map and enum map both is having the strong key reference. It stores strong key reference. Then for searching and getting the value, identity hash map uses double equal to operator. Okay. Whereas weak hash map uses equals method, and enum map also uses equals method. For keys, identity hash map allows to store any type of keys. It is not an issue with that. Okay. Enum map allows to store only enum type of keys. Okay. So enum, you know, right, where we define all the constants. So mostly the constants are being put in enum keys. So we can directly fetch the data using enum. Okay. And we get the constants, and then we can define a key value pair. So enum map, from the name itself, you can get to know like it will accept only enum type keys. Okay. Now, important now, underlying data structure. For identity hash map, it uses array as an underlying data structure. Okay. For weak hash map, it uses hash table. And for enum map, it uses array. So array is very much important. Okay. So underlying data structure, it may ask you, what's the underlying data structure of identity hash map, weak hash map, or enum map, or other maps? So you should be knowing this. Okay. Then iterator is used in identity hash map, which is fail fast. Okay, because it's not synchronized and it is not fail safe. Okay, so it's fail fast. Fail fast means what? If you're trying to modify the existing map, okay, then it will fail. Okay, it will not allow you to modify the existing map. Okay, if you want to modify the existing map, then try using fail safe maps. Okay, which are concurrent hash map. Okay, synchronized hash map. Okay, so these are fail safe maps. So if you do iterator on this hash map, and if you are trying to modify, it will fail fast. Weak hash map will also be fail fast. Okay. And for enum map, it is weakly consistent. Okay. So it may fail, it may not fail. Okay. It depends. For null value, identity hash map allows to store null value. Weak hash map also allow, but enum map doesn't allow to store null value. Okay. So this is again very important. I think this is the last slide. Okay, so I hope you will get to know. Okay, so you have to be a little bit consistent, because these are asked in the interview. I have faced all these type of questions. Difference between synchronized hash map, concurrent hash map. What is a weak hash map? Okay, how does it different from other hash map like identity hash map or tree map? So these are very important. So you should know the difference. That's why I have compiled it and put it up for you, so that you will not have a problem understanding this. So concurrent hash map, synchronized hash map, and hash table. Okay, so hash table will get thread safety. It will map, it locks the entire map object. But this is not the case with the help of synchronized and concurrent map. Synchronized map, it also maps the entire whole object. So in case of multi-threading, it will create a problem. For single thread, there is no issue. But if there are multiple threads who is locking the map, then what will happen? If one thread is coming, it will map the entire map. It will lock the entire map. Okay. And then other thread will have to wait till that first thread has completed the work. Okay. So maybe that first thread is not working on all the buckets. Only one bucket might be that particular thread is working, but still entire map gets locked. That is the major issue. And for concurrent hash map, it is thread safe. Okay. And it locks at a bucket level. Okay. It doesn't lock the entire map. So that is an advantage of concurrent hash map over synchronized. Okay. For concurrent map, at a time, multiple threads are allowed to operate map object safely. Okay. For synchronized map, only one thread is allowed to perform, because it will lock the entire map. And hash table also, one thread will be allowed. Okay. For read operation, without lock we can do, but for write operation, we have to have a bucket level locking. Okay, read operation, there is no issue, right? Multiple thread can come and read the elements of the map. But when you are doing the write operation, then problem will occur. Okay, because if more than one thread will try to modify the same bucket data, then it will create an issue. So there actually we have to perform bucket level locking, so that one thread can acquire the lock on an existing bucket and it will continue the work. And if it gets finished, then other thread will come and acquire the lock on that particular bucket, and then the operation will continue like that. And for synchronized map, every read and write operation requires total map object. So it will log the entire map, and then it will do read and write operation. Same with hash table. Okay. For concurrent hash map, one thread iterating map object, the other thread is allowed to modify the map. and it will not get concurrent modification exception, because concurrent hash map, it is fail safe iteration, so concurrent modification exception will not occur. Okay, so here for synchronized map, so we will get concurrent modification exception. Okay, so in that case only one thread is allowed to iterate over a map, and in that scenario, if other threads are allowed to modify the map, it will throw concurrent modification exception. Okay, same with hash table. For concurrent hash map, iterator is fail safe, we already told you, and for synchronized map, iterator is fail fast. Okay, and for hash table is also fail fast. For concurrent hash map, null is not allowed for both key and value. It is very important. Okay, very important difference. Null is not allowed for both key and values. For synchronized map, null is allowed for both keys and value pair. And hash table also, null is not allowed for both key and value pair. Okay, so only for synchronized map, null is allowed. And for rest, null is not allowed for both key and value pair. I hope you got the idea. And concurrent hash map, the final difference, concurrent hash map is introduced in Java 1.5 version. Synchronized map is introduced in Java 1.2 version, and hash table got introduced in Java 1.0 version. So these are the major differences. I hope you got the clarity. So you have to keep on revising the differences again and again so that you can explain your answers properly. You can explain the differences properly. Okay. So these are the things that I wanted to share with you all. So I hope you understood properly the